Hi all, welcome to Public Cloud Design Tips and Tricks. And in this session, I will try to cover you more on AWS Elastic Kubernetes Service. Uh, so, what are the problem statements? The problem statements are how to manage and orchestrate microservices, how to manage production grade deployments. The solutions again, there are two offerings from Microsoft Azure and AWS. One is Azure Kubernetes Service, another is Amazon Elastic Kubernetes Service. Little bit on Kubernetes again, which is K8. K8 is a production-ready open source container orchestration service. So when you have multiple microservices or multiple containers running in your organization, then Kubernetes is a best fit. What uh, what are the paradigms of Kubernetes? It fits for microservices application and microservices design patterns, especially more independent in deployment and management. Uh, when you have already broken down complex application into smaller services units, those are microservices running in a container, then yes, Kubernetes is a best fit. It always enable more agility and speed. What it means is each independent team can manage microservices independently end to end. That brings agility and speed. Recapturing Kubernetes is there are three parts of Kubernetes. The first and important is the control plan. So control plan contains uh, main four important processes are etcd, kube controller, scheduler, and API server. And the middle one are worker nodes or the worker machines where pods are running. So what pod is? Pod is nothing but a application container where your application is running. What is a runtime? Runtime is a Docker runtime or the Docker images that is running within a pod. What is a kubelet? Kubelet is an agent that keeps talking on the container running in the pod for operational metrics, which is required for the ecosystem of the Kubernetes cluster. And the third one is the consumer, which could be a user or a service that's try to talk to the applications running within the pod. So, in a nutshell, these are the important parts of a Kubernetes. Coming to Amazon Elastic Kubernetes Service, what is EKS? Is a managed service that we can use to run Kubernetes on AWS. So, when you want to run Kubernetes cluster within AWS, then EKS is the service. What it does, it doesn't need a control plane to be managed. So basically, by default, it comes with a control plane which is managed by AWS. Scales the Kubernetes control plane across availability zones to achieve a high availability of 99.95%. What is availability zone? These are the data centers where your control planes are running across. It also integrates or comes with various other Azure services like ECR, Elastic Container Registry, load balancing for ingress purpose, IAM for security authorization and authentications, and VPC for or to create private networks to run worker machines. Now, if you have a Kubernetes cluster running other than AWS environment, then you can easily migrate it to EKS because underneath it is Kubernetes cluster. There are four important steps that is required to run a EKS cluster. Is the first one is to create a EKS cluster. How you can create a EKS cluster is by using API or AWS CLI. It's a command line tool or AWS SDK. Once you have a EKS cluster, then you can decide the compute flavor for your worker nodes. That can be either Fargate, which is a serverless technique, or EC2 based. Once you have the EKS cluster and compute ready, then you can connect to EKS using kubectl. And once you are connected, then you can run your applications or manage your application within the EKS cluster. Now coming to the EKS technical building blocks, there are four important parts of EKS is control plane, worker nodes, serverless, and network isolation. So control plane has four important processes running within. Is first one is API server. It is the gateway to connect to K8 clusters with APIs. So all the APIs that is required to connect to a clusters are there in API server. For example, you can use those APIs to deploy a pod or create a service, or you can do health checks whether a pod is running or not. Now coming to the scheduler, so scheduler is the second process. Eventually, API server talks to a scheduler. So what it does, the scheduler schedule to run a pod, and it keeps watching if a pod gets created newly, or it also assign a available node to a pods. Okay, so these are the important activities of a scheduler. The third one is kubectl control manager. So what it does, it monitors the status of any worker node level failure. So if there is a failure within the worker node, it keeps monitoring that. And if there is any kind of a failure happens, it talks to a scheduler to restart or reschedule it. So that is what it does actually in a nutshell. The fourth one is etcd. So what it does, it stores the cluster specific data and events basically. So why it is required? Because if there is a failure case happens, then to recover the cluster against this data is required basically to recreate a cluster again. Okay, so so in a nutshell, it contains all the platform specific configuration data in key value pair. Important thing is it doesn't contain any application specific data. Uh, Coming to what is a worker node, worker nodes are EC2 instance that acts as a host for the pods actually. Deploy the containerized application. So within EC2 you have pods, and that pod is the containers basically. Serverless is the another flavor of creating worker machines, is the forget flavor. So within the forget, you have tasks are nothing but again the pods basically running within the nodes. It's completely serverless in nature. No need to manage worker nodes here. Uh, the last one is network isolation. So why would you need a network isolation? It helps to secure worker node in your own private network. The nodes run in a private subnet. So basically you have a VPC. VPC has a CIDR range. Within that VPC, you have private subnet. Within private subnet, you have EC2 machines or forget task. And within that, you have pods running, and each pod will assign a private IP in both the cases. So that is how it works. So it's more for security reason. Okay. Now, how to start with EKS cluster? The four essential things that you need to start with EKS cluster is first one is AWS CLE. So it's a command line tool for working with AWS services. Then kubectl is a command line tool for working with Kubernetes clusters. The third one is EKSCTL, which is a command line tool for working especially with EKS cluster that automates many individual tasks. And IAM is the security principle that we use should have permission to different EKS role and other services that EKS users like VPC, cloud formation, and other service linked roles basically. So when you are creating a EKS ecosystems, then you continuously interacting with different other services also. So for that, to talk to them, you need roles and permission, and IAM helps you to achieve that actually. So these are the four important things that you essentially need to start with EKS cluster. The last part is a typical architecture diagram how EKS cluster looks like. Is there are two parts. The first one is your provision control plan, and that comes with AWS, and it runs within the EKS VPC, and you need kubectl command tool to connect to the control plan to talk to the underlying gate clusters. The second or the below part is the worker machines basically, which is running within the availability zone within a private subnet we already discussed, and that runs with the in the customer VPC or the private networks of the customer. So user can connect to those EC2 machines to access those services running in the pod through different mechanism like ingress and other routing mechanism. So in a nutshell, that is how EKS works. If you want to get more into it, then Please follow these references. These are AWS references where you can get more user guides and standard network and design patterns. So that will help you to know more about EKS and start working with EKS. Thanks a lot, and have a good day. Thank you.